We will discuss many things in weeks 5 to 6. We'll focus on sectors, segments of a circle, the arc length, and the measurements of segments of secants, chords, and tangents. But for this part of our discussion, we will focus on areas of sectors, segments, and arc length. So these are the formulas that we are going to use. So area of a sector, pi r squared c over 360, where r is the radius and c is the measurement of the central angle. Area of a segment, so we have pi r squared c over 360. That is just the area of a sector, but we will subtract the area of a triangle, which we will compute or calculate using AB sine C over 2, A and B being the measurements of the two sides of a triangle and C being the included angle, which is in this particular case the central angle of the circle. And then arc length, 2 pi r, that's the formula for the perimeter of a circle, C, that is the central angle, and 360, that is the measure of the full circle. So let us go to our examples. So in our first example, we have a circle, that's circle B. The central angle is 60 degrees right here, and the measurement of the radius is 4 inches. So let us try to calculate the area of this sector. So the area of a sector, let us just copy the formula here. Area of a sector is pi r squared c over 360. Paste right here. So since we already have our formula, what we want to do is to just substitute or plug in the formula, the values that we already have. So we have here pi is still pi. We will not use 3.14 unless otherwise instructed. R is 4 squared. C is 60 degrees all over 360. So for my students, we don't use 3.14 as pi. We just use pi because we are going to press everything in our calculator. So we have, I'll use Mathway for this video, but of course, you are free to use any other calculator that you like. Of course, it's better if you have your scientific calculator. But anyway, let's have pi. Where is pi? Here is pi. And then 4 squared times 60 all over 360. Calculate, and that is our answer. So we can opt for the exact form or the decimal form. We will use the decimal form because you will use your scientific calculators inside the classroom. So we have 8.377, which we will round off to the nearest two decimal places. So our final answer is 8.38. So area of our sector is 8.38 square inches or inches squared, since we all know that area is expressed in square units. Let's move on to our second example. So in our second example, the shaded portion is a segment. So as you can see, a segment is a part of a sector. And then this area right here, I'll shade it yellow, is a triangle. A triangle with two given side measurements, both 7 centimeters, because that is the radius of the circle, and an included angle 100 degrees. So there are different ways and means to find or solve or calculate the area of a triangle depende kung ano yung mga given na data. This time, we are given the measurement of two sides and an included angle. That being said, this is the formula that we are going to use, AB sine C over 2, to calculate the area of the triangle. So I'll copy this formula. I'll paste it here so we can solve for the area of the shaded portion, which is a segment. So basically, we solve for the area of the sector first, and then solve for the area of the triangle, and then subtract the area of the triangle from the area of the sector. So this is gonna be pi. R here is 7, so that's 7 squared. C is 100 over 360 minus AB. Those are the side measures of our triangle. In this particular case, both 7 centimeters. So that's 7 times 7 sine C, which is the measurement of the central angle. In this particular case, that's 100 over 2. And then we use our calculator and press everything. So we have pi, R is 7 squared times 100 over 360 minus fraction 7 times 7 sine, I'll maximize, no? I can perhaps type in sine. So sine, there you go. 100 over 2. Let's check. Pi r squared, 7 squared, 100 over 360 minus 7 times 7 sine 100 over 2. Okay? So that is now our final answer. Let us look at the decimal form. That's 55.166. Again, we want to round off to the nearest two decimal places. So that's 55.17. So area of our segment is 55.17 square centimeters because area is expressed always in square units. Let's have our last example. This is obviously looking for the measurement of that arc. But we are given the measurement of the central angle and the measurement of the radius. So therefore, this is requiring of us to look or calculate for the arc length. So paste the formula, arc length. And then let us substitute our given data. So we have, so that is 2 pi, R is 6. The central angle is with this marking, and this is for our right angle. So our right angle measures 90 degrees. That is always 90 degrees over 360. So we just press that in our calculator as well. So arc length will be equal to fraction 2 pi times 6 times 90 over 360. And the arc length is 9.424. So if we are going to round that off to the nearest two decimal places, that's just 9.42. This time around, it's only centimeters and not in square units because this is not area, this is just arc length.